Hello everyone and welcome to Island Technology's presentation on Power over Ethernet functions in DrayTek VigorSwitches. My name's Darren and I'm the Queensland sales rep at DrayTek Australia and New Zealand. Power over Ethernet or PoE VigorSwitches have the same functions as other DrayTek managed switches, but also supply power to attached devices like IP cameras, IP phones and so on over the Ethernet cabling. This eliminates the need for a dedicated power point and power adapter for those devices. The main objective of this presentation is to help understand the concepts of Power over Ethernet. I'll also explain how to use features such as scheduling to control PoE devices, as well as how to use device check, PoE Priority, and ONVIF surveillance. Stay tuned at the end because we'll be online for 5 minutes afterwards to answer any questions. Don't forget you can also pause the video or skip back anytime if you'd like a longer look at anything or to hear it again. We'll look at several topics, starting with an overview of what PoE is and what it can be used for. Then we'll briefly go over PoE Standards, followed by a look at the various functions available in PoE VigorSwitches. These include scheduled PoE on-off for ports, energy-efficient Ethernet, device check, also sometimes called PoE watchdog, PoE Priority to make sure the most important devices stay up over anything else, hardware monitor, PoE status monitoring, and ONVIF surveillance for IP camera management. So let's start by looking at the power source options available to power up devices. There's 3 ways we can power up network devices. The first one, which all of us will be familiar with, is to use an external power supply such as an AC adapter, which plugs directly into a power point. One drawback here is that it does require a power point nearby, which isn't always the case, so it may require the cost of an electrician to install one. Other than that, this is usually the easiest option if you only have a small number of devices, such as in a home and other simple environments. The next option to power devices is to use a PoE injector. Here, the power injector is placed in between the switch and the PoE devices. Power to the devices is supplied over the data cabling. This method is suitable when a small number of devices need to be powered, but at a certain point it will introduce clutter with lots of cables and power points needed in the data communication cabinet. A much better option in this case is to use a PoE switch. This combines a switch and the PoE injector into a single device, so less cabling is needed as well as only one power source. Only a single data cable from the switch to the PoE device is required to provide it with power and data. It's also a more scalable solution. Let's have a quick look at what PoE is and why we need it. As I just mentioned, Power over Ethernet provides both data and power over a single Ethernet copper cable. It's ideal to use for devices such as IP phones, access points, PoE LED lighting, and IoT devices. It allows easy deployment and devices can be added to the network just by connecting them to the data cabling. It also provides flexibility for placement of devices, for example installing an IP camera in a stairwell. It's also scalable and is able to cover distances of up to 100 meters. Using PoE can also be cost effective since there's no need to install additional cabling or needing electricians to install additional power points. There's also a safety aspect. Using PoE allows the operating voltage to be monitored, and we can ensure that power is only provided to PoE compatible devices. More on that last point in a moment. PoE Standards. There's 4 PoE Standards as shown in this chart. Each provide a different amount of power and have different cabling requirements. The first type is 802.3AF. This provides up to 15 watts of power and 2 pairs in the data cabling is required. This will suit most IP phones, access points, and IP cameras. Next is 802.3AT, which is also known as PoE+. It can provide up to 30 watts of power and is suitable for higher powered equipment such as PTZ IP cameras, video IP phones, or access points with PoE outputs such as the Vigor AP918 RPD. The next PoE standard is 802.3BT, which is also known as PoE++, and a few others like 4P PoE, 4-pair PoE, Alternative A, Alternative B, and Ultra PoE. Here we have 2 types. Type 3 can provide up to 60 watts of power for devices such as video conferencing equipment and multi-radio wireless access points. Type 4 can deliver up to 100 watts of power, which is enough to power laptops and even flat screens. When a PoE device is plugged into a PoE switch port, the DrayTek VigorSwitch will negotiate with it to check that it is PoE capable. The PD discovery process is used as shown in the flowchart on the right here to check if a PoE capable device is attached before bringing up power on the switch port. This will prevent damage to non-PoE equipment attached to the switch ports. PD, incidentally, is short for powered device, so a PoE PD port means that the port receives power, while a PoE PSE port, PSE meaning power sourcing equipment, means that it sends power, so you can plug a powered device into it. DrayTek VigorSwitches use PoE Mode A to supply power to PoE devices. Mode A is also known as end span, and power is supplied over data pairs 1, 2, 3 and 6 in the UTP cabling for both PoE and PoE Plus ports. PoE Plus uses all 4 pairs in the data cable. One term used in PoE switch specifications is power budget, which is the total amount of power available to all PoE ports of the switch. It varies depending on the switch model and can range from 140 watts up to 400 watts in VigorSwitches. What that means is you'll need to do some calculations to ensure that the switch you want to use will have sufficient power to power all of your devices. For example, a PoE switch with a power budget of 140 watts can provide enough power for 4 IP cameras at 30 watts each and an IP phone at 15 watts to give a total power load of 135 watts. Bear in mind also that not all ports on a PoE switch will always provide power. Combo RJ45 ports shared with SFP slots on PoE VigorSwitches, for example, are non-powered. Some products from other manufacturers may only provide PoE out on a set number of ports, so when you're doing your homework, make sure you have enough powered ports for your requirements as well as the power budget you'll need. Now that we've looked at some basic PoE theory, let's look at the features available in DrayTek VigorSwitches. The first feature we'll look at is PoE Schedule. This allows you to turn power off and on a switch port according to a time schedule. For example, you may want some devices such as IP phones to only be powered on during office hours, but not to be used outside these hours, perhaps to reduce unnecessary electricity consumption and data loads. Another one might be turning off the Wi-Fi outside hours. This can be configured on a per port basis, and up to 15 schedules can be configured. To configure the PoE schedule, first go to the Schedule option under the PoE menu. Then go to Schedule Profile tab to create a profile. Select an index number for this profile, let's go with 3, then enable it. For description, we'll call this one Turn Off. Now enter a start date and start time. For duration, let's make it 1 minute so we don't have to wait too long to see how this works. For action, select Power Off. The switch port should be powered off for 1 minute now. Let's just make this apply for once for this test and click Apply to save. The next step is to click on the Port Scheduling tab. We'll say ports 40 to 48 use Schedule 3 we just created. And back to the dashboard, we have an access point connected to port 48, and we can see by the little lightning bolt that it's online and powered by PoE. That reel should kick in any moment. And there it goes. Port 48 has now gone offline, so that AP is now dead in the water. If we wait for a minute, we should see the port come back on and the access point will be online again. I'll just fast forward here to save waiting. And there we go, port 48 is back up and the AP is online again. So that's an example of how port scheduling works. DrayTek VigorSwitches also comply with IEEE 802.3AZ energy efficient Ethernet, allowing the switch to automatically detect idle clients and cable length to adjust the amount of power required. This green networking feature reduces power consumption. This can be enabled or disabled under the Switch LAN EEE Energy Efficient Ethernet Setup menu. The next feature we'll look at is Device Check. You'll find this under the Diagnostics menu in the VigorSwitch. It's a ping watchdog for PoE devices to ensure that attached devices are all working correctly. Here the switch sends out continuous pings to attached devices. If the devices fail to respond after a preset number of attempts, the switch can send an email alert and either power cycle the PoE port, power it off, or do nothing other than send an alert. Power cycling the port will cause the attached device to reboot and hopefully restore it to working order. To configure Device Check, go to the Diagnostics menu and select Device Check. Select the switch ports to use and the IP address of the device to monitor. Also set the ping interval time and the number of retries if the device doesn't respond. For failure action, we can select Do Nothing, Power Cycle, or Power Off. If you want an email alert if the attached device fails to respond, enable that as well. For this demonstration, we'll configure port 48 where we have an access point connected. Select Enable and the IP address of the access point comes up automatically. If that's not correct, you can override it. Ping interval is set to 15 seconds by default, which will do for our purposes here, and we'll retry just once. For failure action, we select Nothing, but we do want an email alert when failure is detected. Click Apply to save the settings. Going back to the dashboard, we can see port 48 is online. Now we'll disconnect the access point from port 48 so the switch will see that it's offline. The link light and PoE LED are now off. Since we have enabled the device check function, we should receive an email alert. Checking our email, we see a bunch of messages from the switch. If we click on one, we see it shows the date and time, along with the device check and the IP address of the device that failed. Keep in mind you'll get a mail alert every 15 seconds, which matches the settings we used here, so you may want to set the ping interval longer if that's a problem. We'll now take a look at PoE Priority. This tool is found under the PoE menu in the VigorSwitch. Here you can assign the priority of PoE devices attached to the switch. High priority devices are assigned with critical priority, followed by high and low priority. If we get into a situation where there's insufficient power to power all attached devices, the switch will shut down low priority ports first to ensure higher priority devices stay online. If there are a number of low priority ports active, then the switch will shut down the highest interface numbered port first. For example, if we have ports 1, 8 and 10 set up for low priority, then port 10 will be shut down first, followed by port 8 and so on until there's sufficient power for the higher priority devices. We can also limit the power for the port, which can be either 15.4 watts or 30 watts. In the example shown here, we've set the power limit to 30 watts. The next item we'll look at is Hardware Monitor. You'll find this tool under the Status menu in the VigorSwitch. The Hardware Monitor will keep an eye on the switching hardware and monitor voltage and temperature. The LED alert on the switch's front port will light up if any adverse conditions are met. This page displays real-time measurements in a graphical format and will keep data history for the past 30 minutes. Under harsh conditions, the switch can reduce the PoE power budget and prioritise high-priority devices. At the same time, it can adjust fan speed if overheating is detected. Here we have a close-up look at the temperature and voltage graphs. Also here you can see the automatic fan speeds based on the temperature of the switch. Below 30 degrees we have the slowest fan speed, but when the switch temperature goes above 85, it will halve the power budget. Above 90 degrees, the PoE function will shut down to protect the switch. Once the temperature drops to 60 degrees again, the PoE function will be restarted. Looking at the switch GUI, Hardware Monitor is under the Status menu page. The upper part of the page shows the 3 temperature measurements. We can see that at 1510 there was a temperature rise. The lower part of the page shows the voltage measurements. Hardware Monitor is always enabled by default, so there's no need to configure this function. Moving on to PoE Status Monitoring. One place you can check on the status of the PoE switch is on the dashboard page. Here at a glance you can see pretty much everything all on one page. You can see device information as well as port status. In the System Information section on the lower right you can see the PoE consumption as well as the temperature and voltages in the switch. Under Status menu in the PoE main menu we get additional information. This includes the switch power budget and total power being used. We can also see the power consumption for each device connected to the switch and the priority setting. There's an option here to manually power cycle a device remotely if it's giving you trouble. All you do there is click on the Apply button for the switch port, GE3 in the example shown here. Looking at the switch GUI again. So on the dashboard we can see the current PoE consumption for this switch is 3.9%. When I place the mouse pointer over it, it'll give me more detail such as power consumed, advertised power and remaining power. In the status option under the PoE menu, it'll show the power status of each port and on port 38 we have an IP camera connected, and it shows that it's currently using 1.8 watts. Okay. We'll now look at ONVIF surveillance for IP camera management. ONVIF is an abbreviation for Open Network Video Interface Forum, which is a global and open industry forum which created a standard for how IP products within video surveillance and other physical security areas can communicate with each other. ONVIF devices are recognized in different VLANs in the VigorSwitch, and it can also display the surveillance topology. It also provides a user interface for video streaming and device maintenance. The centralized hierarchical view displays the ONVIF devices in the status view. The blue icons here are IP cameras connected to the switch, and the grey icons are NVRs. On port 2 in this example, we have 3 IP cameras connected behind another switch which is connected to this port. Images captured by IP cameras can be viewed in real time directly from the VigorSwitch menu page, as shown here under ONVIF Surveillance Video. It also allows the network administrator to monitor and control environments without having to log into each IP camera or the NVR. In the device maintenance submenu, the system administrator can remotely configure time settings and reboot the devices managed by the switch. The General tab displays device information such as if the device is online, the device name, time and date, and the device action. Other configurable settings available further down the page are for ping checking IP cameras or NVRs. In the Network tab, you can assign a static IP address for the IP camera or just set it to use DHCP. And in the Security tab, you can set the protocols that can be used to access the IP camera or NVR. Let's have a closer look at that. On the switch, go to the ONVIF Surveillance menu. In the Topology submenu, we find the centralized hierarchical view. Place the mouse pointer over port 38, which has an IP camera connected. We can see details such as device type, device name, its MAC address, and IP address. Going to the Video submenu, we can see attached cameras listed. We only have one camera here. Selecting this camera allows us to log into it by entering the username and password for it. Once logged in, we can see the video stream from the camera. Moving the camera, you can see the image has also moved. We're seeing snapshots of a few seconds each here, hence the delay in the video stream. Now looking at device maintenance, we can see the 3 tabs I mentioned: General, Network, and Security. We can click on the IP camera to see its information and carry out maintenance tasks, and reboot the camera by clicking on the Reboot button. Under Network, we can configure the IP address details for this camera. This one is set to DHCP. And under Security, we can assign HTTP and HTTPS protocols to reach this camera. It's difficult to manage several IP cameras across different locations and customers, not to mention constantly monitoring to see if and when something goes wrong. A useful feature is that the VigorSwitch keeps pinging the ONVIF IP cameras, taking snapshots from them periodically. If a camera stops responding, the VigorSwitch will send out an email alert and include the latest snapshot, which makes it a lot easier to physically locate the culprit. As I mentioned with PoE VigorSwitches, there's also an option to automatically power cycle the particular port to reboot the camera, which hopefully brings it online again without having to physically go out and find it. Back to the GUI again. On the switch, we go to the ONVIF Surveillance menu. In Device Maintenance, click on the IP camera link. Now in the General tab at the bottom of the page, we have several options. Here we have 2 methods we can use to carry out the device check: auto detect or manual. We can also select which action to perform when a failure is detected, which can be to either power cycle the port, power off, or do nothing. Here we can also enable the option to send an email with a snapshot of the latest video seen by the camera. You won't find the snapshot option under the Diagnostics Device Check menu, so don't confuse that with these ONVIF settings. The mail alert will look something like this. It includes the time, IP address of the camera, and ping check fail message. Attached will be a snapshot image taken from the camera before it failed, which will come in very handy if you have lots of cameras. Okay. So to summarise, we looked at the different ways to power devices, then went into what PoE is and the different types, followed by various functions available in PoE VigorSwitches, which were scheduled PoE on-off for ports, IEEE energy efficient Ethernet, device check, hardware monitor, PoE status monitoring, and ONVIF surveillance for IP camera management. Okay, that's it for me, but please stay tuned. Staff will be answering questions in the live chat on the right of your screen for the next 5 minutes. If you're watching this after the live premiere, please comment below or call or email instead. You'll find more information about DrayTek products on our website at www.draytek.com.au. Feel welcome to email us at sales@draytek.com.au or just give us a call on 02 9838 8899. Don't forget to like and subscribe below, and if you'd like a notification of new premiere videos we're about to launch or anytime we put up a new video, please give the bell a click too. Thanks and bye for now.